And I'm going to stick that at 2 at the moment. Okay. And then what I'm going to do is I'm just going to put 1, 2, and 3 just to remind myself of the counting. And then I'm going to put that equation. Before I do, I'm just going to start off with an initial value. And I used that one before, so I'm going to use it now, 0.02. So the equation was equal to R multiplies by, remember that's a star, and this is our xn value, 0.02, multiplied by open brackets, 1 minus, and again that one there, close brackets. Now, when I pull this equation down, it's going to look at the next one up, but the one thing I do want it always to refer to is this R value. So I'm going to make sure I do the F4 to set that as an absolute address. So when I pull this down now, I get a nice value there, and that value just secures me in knowing that that's just looking at there, that's looking at there twice and looking at there. So that gives me the security that I know I've got the right thing. So let's now take these two cells, and we're going to take this quite a bit down. So let's take this for a journey. Oops, gone way too far now. I want to go to 1,000. So just begin to slow down. You'll notice as you scroll up and down, if you go nearer to the top, it moves faster. And if you pull back slightly, it's a bit like a brake. So I'm just going to take that down to the 1,000 because it's just nice to have a nice, and you can see what's happened already. Can you see how it's converged on 0.5? And that's actually really interesting. That by itself is really interesting. So what's this got to do with scatter graphs? Well, let's have a look at some scatter graphs. Let's use this data for a scatter graph. First thing I'm going to do is I'm going to go to Insert. I'm going to look at the graphs, and it's this one that's a scatter graph. And what that means is that we plot both the X and the Y. We put a dot where the X and the Y meet. And we're going to use this one column with the 1 to 1,000 in as one coordinate, and this one as the other. So one of these, this one will be the X, this will be the Y, and we'll see how that goes. Before we do that, actually, we need to make sure we've selected the data. Otherwise, all we're going to get is a blank graph. So I'm just going to select all that data. There it is. You'll notice as you pull down, by the way, Excel detects the end of the file and just slows down in case you want to end there, which we do. I'm going to click there and I'm going to choose the first one, which is the scatters. Okay, and that's what we've got at the moment. So let's see what that's telling us. What we've got here is the initial values are building up at this point here, and then we get that flattening out. Now I'm going to take this and I'm just going to extend this out a bit. I'm going to move that up. In fact, I'm going to cut it, Control X, or I can go to Home and use the cut tool, but Control X will do the same thing, just because I want these right at the top, and at the moment it's right at the bottom. So let's click up here, Control V to paste, or again paste it, and that's there. And that's really useful because we're going to want to use that again in a second. So what I'm going to do is extend this graph out a bit, and I'm going to just reduce its height a little bit. Now what I'm going to do again, I've just noticed that this is not the grouping we've said. We've said 1,000, and Excel's gone, oh, I think you mean 1,200. And it does that. And if you do that, you can change this. All you've got to do is click, then double click on there. This will open up and this will show you what it's going for. So we're going to say 1,000. And I'm just going to press enter on there. And now that's done what I want. I'm going to close that for now. The other thing is I don't want this chart title, but I do want the background to change. So what I'm going to do is I'm going to use chart design and then go to the format side of that. And I'm simply going to say shape fill, and I'm just going to color the background black. Now that means the font doesn't stand out very well. So I'm going to say text fill and set the text all to white. That works. I'm going to click on the grid here and then just simply choose a lighter gray, nothing too horrendous, just something for it to stand out. And then all I'm going to do with this lot is click on the blue line, and you'll notice all these little dots. That's just showing you that you've now got the data set that's there. And I'm simply going to set that to a nice shade, let's say a nice green there. Okay, set that a little bit further out so we can just see how pretty it is. And a little bit narrower. There you go. How pretty. Now, that's really useful. But the data, it might get lost as we're working through it. So let's just see what happens. So as I increase this number, you'll notice that things change. So now it's gone up, but I've still got convergence. It's still seemingly converting to a single point, and we can see that value there. If we notice with 2, it was 0.5. With 2.1, it now converges 0.52, 0.52381, 2.2. And still getting convergence, but you can see it's moving upwards. Then 2.3. Now these values are going to change. So what I'm going to do is I'm going to fix this. So what I'm going to do is double click on this, and I'm going to tell this that its maximum value I'm going to fix at I'm going to say 1.2, and again press enter, and then we've got that. So that won't keep moving. The other thing I want to do is, we don't know what these actually mean, so I'm going to add a chart element, and I'm going to add an axis title. I'm going to add one to the horizontal, and then I'm going to add one to the prime vertical. Now this one at the bottom, this one is the number of iterations, how many times we've carried out the calculation. So this is the number of iterations. And all I did was click into there, it lets me change it. Same thing here, just double click and delete what's in there. And this is what we call the population. That's what it's looking at. So it's just showing us that population levels at this point just stabilize and continue running. What if we keep going? Well, let's jump a little bit. 2.5. Well, that seems to still behave. So that's really nice. And then 3. And then, oh, hold on. 3 looks a bit peculiar. So let's go back to 2.9. Okay, well, that still looks a bit peculiar. Maybe we want to zoom in. Well, one of the problems is that all the interesting things are happening early on, and we're losing that detail because we've got this going 0, 100, 200, 300, 400. And this is interesting, but really the stuff we want to look at is back here. So what we're going to do is we're going to copy this graph. And we're not going to do this linear progression at the bottom. What we're going to do again is double click on this part at the bottom again, and go to the graph part and look at the axes options, and you'll see one that says logarithmic scale. And we're going to tell it to use base 10. So we're going to put a tick in there, and you'll see instantly it's going 1, 10, and then 10 to 100, then 100 to 1,000. So we get this jump, and that's really helpful. That now gives us a focus on this first 10, and then this is 10 to 100, so less focus, and we've got virtually no focus on this point here. Now this at the end here is where we're converging. So what I'm going to do again is I'm going to take another paste of that in and create another copy of it, but this time I'm going to double click on there, go to the fill bars there, and go to the access options there, and I'm going to set the minimum to 900. Now we can see the very last 100 of our system, and we can see that it's nice, it's relatively flat, it's consistent and working. So at 2.9 everything looks very, very pleasant, and we've got this curve, little bit of bouncing here, and then it seems to settle down to a nice flat line there. So we can see what is happening over the whole scale. We can see a focus at the beginning, and then we can see what's happening at the end. So let's try that 3 again. Well, you might notice that even here we've got fluctuations going on. It's still fluctuating around the point there. But nothing horrendous at that stage, so let's keep our journey. 3.1. Wow. Suddenly at 3.1, notice how this is just alternating. It never settles down to one value. We can see here it's bouncing, and that happens quite early on. It goes up nice and steady, and then these bounce between two values. And you can see how if we just saw this as a normal graph, we might go, well, this is madness, what's happening here? But we can see much clearer what's happening at the beginning stage. We've got this nice gradual climb, and then it settles down to alternating between two values, and that's what's happening there. And let's continue the journey. What about 3.2? Yeah, same thing. 3.3, yeah, bit wider, but same thing. 3.4, yeah, quite happy. 3.5, it looks like we've got to a standard. Oh, look at that. So suddenly we've got a new version. Again, scattering at the top, but what we've got here is this gradual climb, and then there's a initial point, 1 there, 1 there, 1 there, 1 there. So it looks like there are 3 possible points. Let's have a look here. Well, if we start with that one, that looks like that one. So 1, 2, 3, oh, looks like 4. So we've got 4 distinct points there. And then once we get to there, it repeats. So we've got 4 at 3.5. So maybe that's what's happening. Every now and then it will double. So let's try 3.6. And certainly, oh, that's looking a bit more hectic. 3.7. So 3. Oh my good grief. Now, if we have a look at that, there doesn't look, if we look at the bottom graph first, nothing seems to make sense. This seems to be all erratic. Remember, this is the last 100 of that large run. We can see it's got a nice steady climb, but once it starts hitting this point of convergence, this is just bouncing all over the place and looking at the top line. And let's take this to 4 and let's see what 4 does. And we have, well, I can't think of a better word than chaos. And that's basically what we're looking at. We're looking at the behavior of a formula that initially with small values behaves standard rules. When we look at values like 2.8 or 2.9, we get a nice steady result. Once we cross the threshold at about 3.1, we start to see this bifurcation, this 2 stages where it bounces between. By 3.5, there's more stages by it, and by 4, it's just unpredictable. Beyond 4, 4.5, and the graph just really struggles. Everything is way up. You look at these tiny values, it's really struggling with 4.5. So let's lower that back down to where we were. And this is now, by the way, reset my graph values on this side here. These are fine, but not these. If I want to sort those, I actually have to go back in and tell it that the minimum, and I'm going to set that as, or reset it, and then auto, and hopefully that pulls it in. The best way of doing that obviously is to hit 3, and that pulls it nicely. So 4 looks like a really nice number, and when we go beyond 4, everything just goes completely weird. And that's what we're going to look at in the next video. We're going to extend this. We're going to look at the scatter graph from another angle. But these are scatter graphs. Just have a look, by the way. Excel can't even do anything after the number 17. So once you get to there, it's really struggling. These are scatter graphs. And yet look at the amount of information from 3 scatter graphs that we've been able to get. Look at how much data it's conveying to us and what we can do. And the fact that we can change the logarithmic pattern to it, and that we can set the range of the x-axis. We would have done the same for the y-axis. We started to do that. So all of those things are incredibly useful. We can change this so it doesn't even look like a scatter graph. It doesn't look like a graph you've ever seen before. And that's really useful. And in the next video, we're going to extend this a little bit further. And then we've finished with scatter graphs, but hopefully in a more interesting fashion. See you in the next video. So welcome to Scatter Graphs 2, where we're going to continue that journey because I just found that kind of fun. So just to recap, we've got that equation that I was showing you, one called the population equation, and what that's doing is simply taking our R value there and then multiplying that by the value there, and then multiplying that by 1 minus that value there, and then all we're doing is telling this to continue to do that. Still take the 3.9 there, for example, but using the previous value for the other 2 places and doing that all the way down. Now we've been looking at how this works. So 2.9 gives us quite a nice picture, but 3.1 gives us this oscillation. 3.5, and we start to see variation in there to 3.9 when things start to go erratic, and then once we get to 4 it goes quite mad. So what we're looking for now is to look at this a slightly different way. Again, we're going to look at scatter graphs. We've got 3 here, but let's see what else we can do. So what we're going to do is I've created a new worksheet called Scatter Graphs 2. I'm going to go to B1 and I'm just going to type in 2.5. I'm then going to go down to here and put 2.6, and then I'm going to go here and put 1 and 2. So I've got those points there. Now I'm going to start off with an initial value, and if you remember with here, we started with 0.02. So I'm going to start off with 0.02. Now clearly these numbers up here are going to be our R value. So the value up here. And we're going to start that at 2.5, which we know is a nice stable straight line. Once we get to the 900 point, it's just a really nice straight line. So we're going to start somewhere nice and safe, but rather than just go jumping, we're going to go from 2.5 to 2.6 and obviously 2.7 onwards. So we've got this here, and that works quite nicely. And what we're going to now do is do the sum. So we're going to equals. Now, usually I would lock straight onto this cell, but actually, as I pull this formula this way, as I pull the formula this way, then what I'm expecting to have happen is I need it to move from the 2.5 to 2.6. So I don't want it to keep being in B, I want it to move to C, D. So we now know that I'm just going to put the B, but I do want it always to be in row 1. That's the important side. So I'm going to do $1. So that's locked into that first cell. Then what I'm going to do is tell it, okay, but the next thing I want you to do is take this and multiply it. Again, we know open brackets 1 minus that again, close brackets. So it's $1. So look at this cell here, always this cell for this column, but when you move it across, change it to the next column along, and then multiply that by this cell here, but don't keep it locked. So therefore it's relational, it's relative to where it is, and then same thing as the last cell. And if we do that, we get a relatively nice number. Now, what we should be able to do then is just replicate those this way, just to give ourselves the idea that that works. Now, what I'm going to do then is I'm going to pull this one just downwards. Now, I want to do this for about 200. I've actually gone past that so I'm going to go, let's stick to 400. That's quite nice. And since I shot past, there's nothing wrong with that. Remember, if I want to jump up to the top, Control and the up arrow will get me there. Now this has changed to 1.02, so I've got a negative number, but we're just going to tell it to keep it at 0.02, and we get a nice figure there. So we can now simply take that whole column there and then just take that and fill one across. And since we don't now need those numbers, and again just shift up, and since we don't need to worry about having these numbers involved, we've now got everything we need to take that, and we're going to just take that across to 4. Now it's not easy to see the top value, so I'm going to do something that we haven't seen before, and we will talk about this much later on. But what I'm going to do is I'm going to click in that cell there. And that cell there just simply, it's just the bridge between this one and the top one. That will make sense in a second. And then what I'm going to do is I'm going to go to View, Freeze Panes, and I'm just going to say Freeze Panes. Now what does that mean? Well, look at this top one. As I scroll, notice it doesn't move. So I can now see the 2.5 for the whole time. And that's really helpful, because when we come to pull that, I'm going to be able to see where the 4 is. Why did I do that particular cell? Because it said anything before freeze, stop that cell from moving. And I was in that top corner, which means that when we put it this way, not only does it do it for the top, but it also does it for the side column. So for this one here. So way past what we need. And the nice thing is with the autofill there, if we take it back, it just removes what we don't need. So now we've got some nice values. And that should give us everything we're looking for. But we can see quite quickly that something's gone awry right at the beginning. So let's just check if everything's gone. No, that seems to be fine. Doesn't seem to be a problem there at all. Now, the only thing that I do notice is that I've got some negative numbers in there, and I wasn't expecting those. And then as I look closer, I've realized I've made an error by pulling those down. So what I did was I had row 1 and it's replicated those. And I did that just to highlight the fact that it's quite easy to forget what you're working on and then replicate the wrong error. And that's perfectly fine. All we've got to do now is pull that right to the bottom. So it's repairable. But if you get odd numbers, just check around. What have you done that shouldn't have happened? You wouldn't have noticed those shouldn't be negative numbers. It's just one of those things that I've seen before. So we've got that. There it is, nicely stabilizing there, nicely stabilizing around here. There it is there, stabilizing. So we've now got our data points, and that works really nicely. So what are we going to do now? What we're going to graph this. We're simply going to graph this by going to the insert menu and going to the scatter graph and then just clicking the scatter graph symbol. That's going to give us a scatter graph, and all I'm going to do now is right click. Now because we set the other one up, this is already looking at the right direction. I'm then going to go move chart and tell this to move it to a new chart, and let's call this one scatter graph, and again let's call it scatter graph chaos, simply because we deleted the other one. So we have that here, and you can see all the data series, and what I'm going to do is I'm just simply going to delete that key. I'm also going to delete the chart title at the moment just to give myself a little bit more space. And look at that. Now, next thing I want to do is I want to get this a little bit more refined. So I'm going to click on any of the data points, and you can see I've selected those ones. So I'm now going to right click and I'm going to change format data series. I'm then going to go through, and what I want to do is I want to change its size. I do that by just clicking on the marker, and then I can go down and change the marker options, change its size, make it smaller. And you can see already as I click, they become finer. So you can just about see some of them there. Now I need to click away and click on another series, and unfortunately, yep, you got it. You're going to have to do this on each one if you want to do that. So it just helps define what we've got there for each one. But what that allows us to do is simply clear up a lot of these points and start to see the graph a little bit neater. Now, just going to reduce this last one just to start to see what we're looking at. Now, there are longer process ways in which I can make the dots smaller, but that works quite nicely, and I'm getting the sense of what I'm looking for. But what am I looking at once I've tidied that up? And here it is, the bifurcation diagram. Here's the expression we've been looking at here. And so just to prove I'm not been lying to you. And this is the result. This is the diagram that you can generate from this. Now, this isn't an Excel diagram, but it just gives you an idea of what we're trying to achieve. And if we define those points as small as possible, then you'd start to see this. And what we're seeing is, in this line that's going along here, this is where it's settling down, it's converging on a single value. And then when we get to roughly 3.1, it separates out into two. So it swaps, as we saw, it swaps between two values, that gap growing bigger and bigger, until suddenly it swaps to 4 points. Around about 3.5, so we start to see 4 points, and then around just getting up to 3.6 we get 8 points, and then around about 3.6 it suddenly goes unpredictable. There's clearly a rule to this, we've got it, it's down there, but it's become unpredictable. And then a little way on we suddenly got a little more prediction, we can see a prediction, and then unpredictable again. And then another narrow band of prediction, then nothing we can predict. And then another wider band of prediction, and then basically chaotic from there. Then we got these little lines, very small lines of calm, of peace. But amongst that, we've got this erratic nature where it's not possible. If you gave me a condition, let's say 3.8 in that equation, it's not possible for me to tell you which value you would be on without knowing other bits of data around it. It's not possible to predict. So there's chaos. There's still order here. Chaos in mathematical terms doesn't mean it's completely unordered. There is a sense of order there, but it's too complex for us to predict and forecast. And I think that's quite amazing. And if we look back at our spreadsheet, we've got the start of that. We're using a program that you've got on your computer that most people use to hold or store data for no apparent reason. And yet we're performing a complex mathematical function and actually producing a graph that shows the beginnings of a branch of mathematics we know of as chaos theory. We can look back at, we can even use this graph to see what that means. So as we say, once we approach, if we look at our main graph, if I go back to there, we can see that we get a single value around about up till about 3. Once we get to 3.1, it oscillates. So let's stick with what we've got here. We've got 2.5, single value, settles down. But if we get to 3.1, it oscillates. Then if we look back, we can then say, okay, well, what about 3.5? That seems to go to 4. So let's choose 3.5. So in there, 3.5. And we can see 1, 2, 3, 4 starts again. Then the next change we can see is close to 3.6. So maybe 3.58. Let's try that one. 3.58. And that looks like we're getting there, if not quite. So starting that one, 1, 2, 3, 4, 5, 6, 7, 8. And then we start again. So we got there. But what about 3.6? 3.6, well, we can see replication there, but it's not so predictable. 3.8, and this doesn't ever repeat. We're at 900, this doesn't repeat, and then it goes all weird. We've got a little bit of predictability here, so we can see some rhythms in there, but it's complex. And that's what we've got. Just using scatter graphs, we've got these lovely graphs showing us. We've seen a logarithmic approach, and we've even used another scatter graph to produce this bifunctional diagram showing us the whole thing. And we've got data for a single value over 1,000 points, and we've got a whole series of values spread over a wide range there. You've also learnt in the interim how to not just do scatter graphs, but equally control arrow to the top, control arrow to the side, how to freeze panes. So not bad for a single revision or review lesson. Okay, see you in the next video.